Hello everyone, welcome back. This is Engineer Hussein Mwasapi. So in this video, we'll be looking at how to find the intervals where the function is increasing or decreasing, or rather is constant. Now before we begin, do not forget to like and subscribe to the channel. Alright, let's get to it. Now basically explain this since it's under the conditions of differential applications. I will simply just use examples to help you understand exactly how to go about solving such problems. Say we're being asked to determine the intervals where the function is increasing, decreasing, or is constant. Let's say we have a random function as f of x is equal to x squared minus x minus 6. Now, to determine the intervals that are necessary, we need to follow some steps. The first thing we need to do is to find the critical point. Now, the critical points are the values of x at which the first derivative is equivalent to 0. After that, the second thing to do is now test the points from left and right and read the story. Now, if you test the points from left and right, it will tell you something about the function. Now, one thing you should understand is this. Whenever you find the critical points at, let's say the critical points for a particular function given, at times you'd find that if you differentiate the function you have in question, you might just have a constant. In a case where the first derivative, let's say f prime, is equal to a constant, which is just a random number, it implies that the particular function is neither increasing nor decreasing. Therefore, it is just what? Constant. Now, with that said, let us try and solve the initial problem that we have. So like I said, the first thing we have to do is to find the critical points. So let us find the critical points of this function. Now differentiating it, we'll have f prime of x being equivalent to, for this polynomial, I'll basically use the power. Applying the power, we'll have 2x minus 1. Now, the critical points are the values of x at which the first derivative is equal to 0. So I'll let the first derivative, which is f prime of x, equal to 0. Now, with that said, it implies that what we have now is not this. Rather, we'll have 0 being equal to 2x minus 1. Now, mathematically speaking, we are allowed to flip this. So this is 2x minus 1 being equivalent to 0. At this point, we need to solve for x because x is now a critical point. Therefore, the minus 1 goes the other side, and you have 2x being equivalent to 1. Now, solving for x, we have to divide both ends by 2. And it implies that x is now equivalent to 1 over 2, which is basically half. Now, it's not in all cases that you always have one value of x. At times, you would have more than one value of x. You might have two values of x, or even more. Now, in this case, we're only having one value of x, which is half. Now, once we find the critical point, or the point in this case, we now just have to test the points from the left and the right and read the story. Now, how are we going to test it? We're going to use a number line. So let's apply a test. Now, we know this is, let's just pick a random point. This is half. Now, we need to pick from the left-hand side of half and the right-hand side of half. Now, you can pick any number of your choice. Literally any number. Once you pick that number, you have to now test it in the first derivative and see what you'll get. Now, if I read it from the left-hand side, I can get a number such as 0. I can get 0 from this side because I just want to get whole numbers in this case. And I can get 1 the other side. On the left, I have 0. On the right, I have 1. I'll test it on 0, and I'll also test it on 1. Now, these numbers are not numbers that are given. You just have to pick any number. If I wanted, I would have picked -1, -2, any other number on the left-hand side of half. Just pick 0 because 0 is the closest, and 1 because it's also the closest, and it's a whole number. After that, I'll test it on my first derivative. My first derivative, I'm having f prime of x being equivalent to x minus 1. Now, evaluated at 0, I'll have 2 times 0 minus 1, and f prime at 0 is minus 1. Now, once you evaluate the point that you're testing in the first derivative and find that the answer you get is negative, it means that from the left-hand side of the point that you picked of that critical point, the value was decreasing, because negative simply means it's decreasing, while positive simply means it's what? Increasing. So from all the numbers on the left-hand side, all these numbers this side are going to make the function to decrease. So from all those numbers we can think about to where half is, our function will be what? Decreasing. This means that from, I would say, let's pick the intervals from -infinity to 0.5. I cannot include half because half is not really a point. I have to pick the left and the right, not really at the point. So from these intervals that I've actually picked, the function is what? Decreasing. So f of x is decreasing. So now we have only stated one interval for decreasing. Let us also test it on the right hand side and see what we get. So if I erase this portion, and see to it that I try to evaluate, on the other side I pick 1. So now f prime of x at simply 2x minus 1. Now f prime of x at 1, what are we going to get? So we get f prime at 1 to be equivalent to 2 minus 1, and f prime at 1 is basically positive 1. Now in this case we get a positive answer, which means that as we move from this point to all the positive or all the numbers on the right hand side of half, we'll be having an increasing function because it's now positive. Therefore, we will say that from the interval of 0.5 to positive infinity, f of x is increasing. So these are basically the intervals that determine its increment and decrement. Therefore, in the end, we can just say, therefore, f of x is increasing through the intervals and the intervals are it's increasing from the intervals of 0.5 to positive infinity and decreasing through the intervals which is minus infinity to 0.5, like that. Now, basically, at first glance, this might not be that easy to understand. So let us look at another example. Let's take, for instance, we have another function, say f of x, and this is equivalent to 3x minus 4. Remember, the first step is simply just to differentiate this. Once you find the first derivative, we need to determine the critical points. But remember, in this case, if I find my first derivative, I'm only having 3. Now, if I was told to find either the function is increasing or decreasing, and I find that the first derivative is giving me a constant, such as maybe 3, this just simply implies that the function in question, f of x, is neither increasing nor decreasing, therefore is constant. I hope it's clear. Now let's look at the last example. Say we have a function g of x, and this function is equal to 2x cubed plus 3x squared minus 36x. Determine the intervals where the function is increasing, decreasing, or constant. So basically, the first thing to do is to find the first derivative and look for the critical points. So the first derivative here, we say g prime of x is equal to, applying the power rule here, we'll have 6x squared plus 6x minus 36. Now to determine the critical points, since here we're having an expression, so we can find the critical points, we'll let g prime of x, which is the first derivative, equal to 0. Therefore, we'll have 0 being equal to 6x squared plus 6x minus 36. Now this can be reduced. There's a number that can go into 6, 6, and 36, and that number is 6. So we multiply both ends by 1 over 6. So this will be 0 being equivalent to x squared plus x minus 6, because 6 into 36 is 6. Now we can write this in the same form as x squared plus x minus 6 being equal to 0. Now, once this is written, we can determine the values of x by using the sum and product technique. So let's find the sum and product of this particular equation. Now the sum is 1, the product is minus 6, the factors are basically minus 2 and 3. Now remember, when the leading term has a coefficient of 1, this can also be just written as x minus 2 x plus 3, and this is equal to 0. This tells us to say that x is equal to 2, or x is also equivalent to minus 3. Now, having the critical points, these are the critical points, mind you. Having the critical points doesn't necessarily mean we have solved everything. The next thing to do is to test the critical points and read the story. Alright, so let's see how we can read this. So since we have x being equal to 2 and x being equal to minus 3, our tests will be in this form. So let's say if this is 0, and let's say we put, this is a negative infinity and this is positive infinity. So I can put positive 2 somewhere there, negative 3 somewhere there. These are just arbitrary points. Yeah. So let us try and test these values. Let us test from the left hand side of what? Of minus 3. From the left hand side of minus 3, we can pick a number like minus 4. Okay, let's say from the left of this guy, let us pick x is equal to minus 4. Let's read what happens to that particular function. All right, so now let's say the first derivative, since the first derivative, is g prime of x being equal to 6x squared plus 6x minus 36. Evaluating the first derivative at minus 4, we'll have 6 times minus 4 squared plus 6 times minus 4 minus 36. G prime at minus 4 is equal to, now what is happening here? We're going to get a positive 6. Now, simply because it's positive, we need to understand that it's going to be what? Increasing. Therefore, the first aspect is for us to understand that it's increasing. From the intervals, remember, this is coming from negative infinity. We picked a point from all the negative values we can think about, any random point. If you want to pick negative 5 or negative 6, your value would have still come out to be positive. This implies that from negative infinity to the point of interest, which is minus 3, and not including it, our function is increasing. Now, if we pick a point on the right hand side of minus 3. From the right hand side of minus 3, what point can we pick? We can pick 0. So at x is equal to 0, what is happening? G prime at 0 is equal to 6 times 0 squared plus 6 times 0 minus 36. G prime at 0 is equal to minus 36. Yeah, minus 36. I had a glitch in my thoughts. Yeah, it's a minus 36 that we're going to get. Now, simply because it's negative, this is negative, we need to understand that the function is decreasing. Now, it's decreasing from which interval? From -3 to any point. Because if I can pick any point here, any point there, from the right hand side of minus 3. I can pick any random point. Now, if you look clearly on the number line, pick any random point. I can pick any point, but not any point that includes 2. So this is from minus 3 to positive 2. So any point along this portion here, my function will be decreasing. Now, let us try and read this function. Just erase this. So 36 there. And let's try and read this function at x is equal to 2. Now, if I pick points from the left-hand side of 2, I'll simply get the same condition that I got when I picked the point from the right-hand side of minus 3. I hope that is clear. So I'll only pick a point from the right-hand side of positive 2. And that point can roughly just be any number, it could be 3 or 4, but we'll go for 3. So this is G prime, remember? So at x is equal to 3, what are we going to have? So G prime at 3 is equal to 6 times 3 squared plus, this was x, 6 times 3 minus 36. Therefore, G prime of x will end up having a value of, if we clear this out properly, we'll have 6 times 3 squared plus 6 times 3 minus 36. And we'll have positive 36. Now, since it's positive, it means that the function is increasing. So we can say this is increasing from the interval of 2 to positive infinity. And these are the intervals at which the function was increasing or decreasing. I hope it's clear. If you have queries, you can always reach me on WhatsApp on the line 077-149-5252. Be mindful that under this aspect, when the first derivative is positive, then the function is increasing. If it's negative, it's decreasing. If the first derivative gives you a constant, it means that the function is a constant. But what I meant by the first derivative being positive is that if you test the critical points at the first derivative and you find that the answer is positive, then it's going to be increasing. While if it's going to be negative, it's decreasing. I hope that's clear. Alright. Thanks for watching. Remember, slow progress is better than no progress. And let's remember to strategize before becoming a statistic. Let's try and push for that A+.